This video, 28 days until the GCSE maths exam, paper 1. Today's topic is angles and polygons. So we'll look at angles inside polygons and angles outside polygons. And we'll look at how we might arrive at formulas that will help us out there and answer a couple of questions. So the first thing we're going to look at is the angles outside a polygon, or the exterior angles of a polygon. So I'm going to click to reveal an animation, and I just want you to look at what's going on. Okay, so in each of these images, these are all polygons. These are all regular polygons, in fact. So we've got an equilateral triangle, a regular pentagon, and a regular hexagon. And what's going on in each of these is we've got exterior angles drawn. And what this is demonstrating is that when you collapse a shape down, when you make the side lengths down to 0, you'll notice all of the angles meet at a point, and we know what happens when angles meet at a point. So we've got this triangle, this is an exterior angle coming in, and it meets at a point and it forms a circle, and we know the angles around a point add up to 360 degrees. Okay, the angles in a full turn, angles around a point. Okay, so we're going to use that fact. So we're going to look at 3 questions involving exterior angles and polygons. So let's look at this. We've got a pentagon, 5-sided shape. We just saw on the last slide that when we collapse this down, all of the exterior angles are going to make 360 degrees. So what I'm going to do, and I wouldn't do this every time I do one of these questions, but just to get you thinking about what sort of formula we might use, if I continue the lines off in the same sort of orientation. So I'm going to point forwards here, point off here, draw an angle, point an angle off here, and one off here. If I collapse it down, all 5 of those, so I've got angle 1, angle 2, angle 3, angle 4, angle 5, all 5 of those are going to add up to give well, 360 degrees, because the angles in a full turn are 360 degrees. So in this case, I've got 5 angles. They're all the same size. It's called the size of the angle x. And so 5 lots of the same angle makes 360 degrees. So each one of those, each angle is 360, divide 5, and that is 100. No, it's not. If I double top and bottom, we get 720 over 10, and that's 72 degrees. Okay, maybe I should have reached for a calculator, but there we go. So each one of those angles is 72 degrees. So there we go. Now we can generalize that, and we can get a formula from that. So the size of one angle, okay, so x, the size of one angle, is 360 degrees, and it's always going to be 360 because it always meets at a point, and we know the angles around a point are always 360, and then we divide that by the number of sides. Okay, so this is a formula that you should probably know. So let's say what each of those things are. X is the size of an exterior angle. Size of an exterior angle, just one of them. 360 doesn't need an explanation, but the n is the number of sides that the shape has. And I should say this only works for regular shapes. This is a regular pentagon. Every side is the same length. This formula can only use that. The fact that they all add up to 360, that's always true, but they're only all the same size, and we can only use this formula for regular shapes. Let's look at another problem using that formula. So this one doesn't have exterior angles drawn on, but I could draw one on. Okay, here's one. Let's give it the label. Let's give it the label X, just like the last one. So the size X is 360 divided by N. So for this a polygon with 9 sides, the nonagon, X is 360 divided by 9. which is 40 degrees. Okay, and one more, you might not be given the diagram. And you could be given a simple diagram that just shows you, well, imagine this shape where I've only got part of the edge and the exterior angle is 30 degrees. Now you can't do anything like count the number of sides, you have to use the formula, and this is why the formula is a need to know bit of information. So can you remember it? It's x, the size of one exterior angle, is 360 degrees divided by n, the number of sides. Okay, so for this one, the size of the exterior angle, which is 30 degrees, is equal to 360 divided by n, the number of sides. So we've now got an equation that we can solve. If I take this, multiply through both sides by n, so if I multiply both sides by n, on the left I get 30n, on the right I get 360, and then divide through by 30, I get n, it's 360 divide 30, that's the same as 36 divide 3, which is 12. Okay, so it turns out this side, this shape is it's a dodecagon, it's a side with 12 sides, a shape with 12 sides. Right, moving on now to looking at interior angles. So instead, we're now looking at interior angles, the shapes inside a shape. This one is a little bit more obvious. So it's, there we go, there's one interior angle. This is a regular octagon again. So it's got all of these, it's got 8 angles inside, and they're all the same. There they all are. Now, the formula for this one is a little bit tricky. I'm just going to show you where it comes from. What we do is if you pick one corner, one vertex of our shape, and then connect it to every other vertex, every other corner that it's not already connected to. So, sorry, I'm just drawing some slightly dodgy lines here. So connect it to every vertex, every corner we're not already connected to. We get a set of triangles. So I've got triangle 1, I've got triangle 2, triangle 3, triangle 4, triangle 5, and triangle 6. Now, each triangle contains a total of 180 degrees. So that triangle 6 there's got 180, we've got 180 in the next one, 180 degrees in the next one. So I could draw on all the angles. Every triangle has 180 degrees worth of angles in it. So I've got 6 triangles, and each triangle is 180 degrees. So if I do the calculation, 6 times 180, it gives us 1080 degrees, right? That is the total of the interior angles. Okay, so if I add up all of the angles in this octagon, it's 1080. Each one of them then, because I've got 8 sides, it's 1080 divided by 8 is 135 degrees. Okay, so that is the size of one interior angle. Now, if you're looking for a formula, what I did there, what the shortcut is that number 6 is 2 less than the total number of sides. So the total interior angle can be calculated by doing n, the number of sides, take away 2, and then multiplied by 180, because that's the angles in a triangle. Okay, that's another need to know formula, absolutely worth learning ahead of your exam. Okay, and this is why it might be worth learning, or in fact, so it's worth knowing that formula. So the formula for the total interior angles was n minus 2 times 180. Okay, we're told this is a 10-sided polygon, so the total of the interior angles is 10, take away 2, times by 180. So it's 8 lots of 180, and I'm reaching for my calculator here. That's 1440 So the size of each interior angle, so the size of each angle is 1440 divided by the fact that there are 10 angles, that's 144 degrees. Okay, we're now going to look at a couple of exam style problems, and I'll just talk you through my approach. I've not seen these questions before making this video, just going in blind and going to talk through what I would do. So we've got the size of each interior angle of a regular polygon is 156 degrees. Work out the number of sides of a polygon. So I would start with a sketch. So I know that the size of an interior angle is 156 degrees. Now I'm going to say that the formula about interior angles in polygons is quite awkward to manipulate. So what I'm going to do is consider the fact that if I extend the angle off and I think about the exterior angle, okay, what might that relationship be there? Well, it's on a straight line with the 156 degrees. So the exterior angle is 24 degrees. Okay, that's the exterior angle. And the reason I've done that is the exterior angle formula is really easy to manipulate. So the exterior angle formula is x is 360 divide the number of sides. And so the exterior angle 24 is equal to 360 over n. Let's work that through. Multiply both sides by n. 24n is 360. So n is 360 divide 24. Okay, reach my calculator. 360 divide 24 is 15. Okay, so this is a 15-sided shape. Don't know what the name of a 15-sided shape is. There we go. Right, number two, this is a classic, shapes being stuck together, and then we have to find the size of an angle between them like this. So for this, well, I think what I'm going to do is find the size of angle A there, and also find the size of angle B there, and then I know the situation with these three angles is that they add up to 360 degrees because they're angles around a point. So let's lay out my working like this. Okay, let's find angle A. So I've got A is an angle in a hexagon, so I'm going to apply the formula n minus 2 times 180 to find the total angles. So I've got 6 sides, take away 2 times 180, that's 4 times 180, which is 720. So that's the size of all of the angles in the hexagon. And then if I do 720 divided by 6, because there's 6 sides in that shape, then that's 120. Okay, so A is 120 degrees. Okay, then what I'm going to do is find angle B. By similar working, it's an octagon, so I'm going to do 8 minus 2 is 6 times 180. 6 times 180 is 1080. Divide by 8. So 1080 divided by 8 is 135 degrees. So that means B is 135. Okay, so I now know 2 of the angles sitting around the point. I'm then going to extract this local situation, this bit just in the middle. So just thinking about that middle bit, we've got 120, 135, and x. And I know that x plus 135 plus 120 is equal to 360. 135 and 120 makes 255. So x plus 255, 360. So x is 360, take away 255. So x is 360, take away 255, which is 105 degrees. Okay, there we go. Right, a similar problem then. So more geometry. So 2 regular pentagons and an equilateral triangle. This time I'm looking for the angle DEH. Okay, what that is the angle that it's formed by D to E to H. Okay, which is this one here. Right, so let's write down what we know. I know the angle inside the equilateral triangle. It's an equilateral triangle, so it's 60 degrees there. And I know that these two angles, let's draw them in green. So the two angles in the pentagon are the same because they're both the interior angle of a regular pentagon. So let's find the angle in a regular pentagon. So again, I'm going to use that formula n minus 2 times 180, which would be 3 times 180 is 540. And then I need to do 540 divide 5 is 108. Okay, so each of those angles is 108. Okay, and then let's think about that situation right in the middle. So I've got 108 plus 60 plus 108 plus, let's call it x, the unknown, plus x, all make 360 degrees because they're angles around a point. If I add up those three numbers, 108, 60, and 108, they make 276. Okay, solve that equation, we get 84 degrees. Okay. So there you go, there's interior and exterior angles and polygons, and the formulas, where they come from, and a couple of problems. Hope that's been helpful for you in your exam preparations.